Hello students, today we are doing a new topic, that is dihydrogen, and in this topic we will do its occurrence and mainly the preparation methods. So before starting this topic, subscribe the channel Chem Tutorial and press the bell icon. Now let us start with the topic dihydrogen. Why the name dihydrogen? Actually, its earlier name was hydrogen. Nowadays it is called dihydrogen. Since its atomicity is 2, it consists of, hydrogen is a gas, very light gas, rather it is the lightest gas which contains 2 atoms of hydrogen. Atomicity is 2, that is why its name is dihydrogen. It mainly occurs in nature in the form of 3 isotopes, and the names of 3 isotopes of hydrogen are protium, which is most abundant, deuterium and tritium. Protium is having 1 proton and no neutron. 1 proton and 1 electron is there. There is no neutron in this isotope. In deuterium, hydrogen atom has 1 neutron and 1 proton. Hence, its mass number is 2. Protium is having atomic number 1, mass number 1. Deuterium is having atomic number 1, mass number 2. Tritium is having atomic number 1 and mass number 3. Hence, number of neutrons in the protium is 0. In deuterium there is 1 neutron. In tritium there are 2 neutrons. Tritium isotope is radioactive isotope of hydrogen. So this was all about its occurrence. Now let us start with the preparation methods of dihydrogen. First method we will do, most common method, by the action of water on the metals. Very reactive metals, we know that they react with water, giving dihydrogen. Preparation methods. First method is reaction of active metals with water. Very reactive metals like sodium, potassium, calcium, etc. they react with water to give a base, and dihydrogen is also produced here. Taking the example of sodium with water, so see here that base sodium hydroxide is generated here, and along with there is formation of dihydrogen. So we need to balance this reaction this way. Similarly, potassium and calcium are also one of the reactive metals. Hence, they also react with water giving rise to base and dihydrogen. Similarly, in the case of potassium, you can see that potassium reacts with water giving rise to potassium hydroxide and dihydrogen. So these are active metals. Same way calcium also reacts with cold water. Metals which are less reactive, they act with water on heating. and they generate in those cases oxide is formed along with the formation of hydrogen. For example, take the example of magnesium and zinc. This is very reactive metal. This is little bit less reactive metal like magnesium. It gives oxide. Zinc also reacts on heating. Magnesium also reacts on heating. Dihydrogen is formed here. So these are less reactive, or you can say moderate reactivity. Then coming to few metals which react with water also, and dihydrogen is formed, but the reaction takes place at very much elevated temperature, or you can say that reaction is with the steam, not actually with water, but the reaction takes place with the steam. For example, the case of iron. Iron reacts with water, not actually water, but reacts with steam at temperature more than 1000 degree or 1000 Kelvin. So the reaction with iron is, this is gaseous water, means it is steam. Reaction takes place at very much high temperature, more than 1000 Kelvins, and there is formation of oxide of iron plus dihydrogen gas is formed here. So here balancing it. Now next method of preparation. This was the first method, that is the reaction of metals with water. Very reactive, middle reactivity, then less reactive metals. Then second method we are discussing is electrolysis of water. By the electrolysis of water. Very common method, we know it. When electrolysis of water is carried out, hydrogen is produced at cathode, and at anode oxygen gas is obtained. So how the reaction takes place at cathode and anode, we will discuss it separately. So at cathode, you know that when electricity is passed through water, it forms, actually this overall reaction is like this, and when we write it stepwise, H ions, OH ions are formed. So at cathode what happens? H ions, they gain electrons, forming H atoms. H atoms combine then to give dihydrogen gas, and the reaction taking place at anode is OH ions, they lose electrons, then These they give dihydrogen plus they give water plus oxygen. So this is gas, this is also gas. This is being liberated at cathode, this one at anode. Now coming to the next method, that is by the action of alkalis on metals, then acids on metals. First, the action of alkalis on metals. Metals like beryllium, tin, aluminium, etc. They also react with bases to give dihydrogen gas. Let's take the example of third method, by the action of metals on alkalis. So here the metals which react with alkalis are beryllium, aluminium, tin, zinc, etc. These are the metals which react with the alkalis. For example, reaction between beryllium and sodium hydroxide alkali, it gives rise to, the common general reaction is metal plus base giving rise to salt plus dihydrogen. So here a salt formed here is sodium berylate, that is Na2BeO2 plus dihydrogen is generated here. This gas is formed here, and this is sodium berylate. And this is formed on heating. So again we are going to balance this. Now similarly we can write the reaction with tin, aluminium, etc. Aluminium also reacts with sodium hydroxide and it reacts in the aqueous medium. So here the salt formed will be sodium metaluminate. And dihydrogen is also formed here. This is sodium metaluminate. So let us balance the equation. Similarly, tin also reacts with sodium hydroxide in the presence of water, means aqueous sodium hydroxide. So here the salt formed will be sodium stannate. Na2SNO3 plus dihydrogen is formed here. So this is the action of the metals with the alkalis. The next method we are discussing is the action of the metals with acids, which is most common method. So here again salt and dihydrogen is formed. The most common example we usually do, which is also one of the laboratory methods, that is the reaction of the zinc metal with the sulfuric acid. So metal plus acid, again the product is salt, zinc sulfate plus dihydrogen gas is formed. It is one of the common laboratory method. Magnesium also reacts with HCl, giving rise to magnesium chloride plus dihydrogen. Iron also reacts with HCl, giving rise to iron 2 chloride plus dihydrogen. Coming to next method, that is one of the important commercial methods also, reaction of water with coke. This reaction is also known as coal gasification. Important reaction for the commercially very important reaction to prepare dihydrogen. We call it reaction of steam and coke also, or it is also known as coal gasification reaction. So it is a reaction of the coke, that is carbon, solid form, with water in the form of steam. This is in the form of gaseous. Temperature maintained is 1270 Kelvin in the presence of catalyst, nickel, etc. So the product is a mixture of carbon monoxide and dihydrogen gas, and this mixture is known as water gas. So here you can see that hydrogen is formed, but along with a mixture of carbon monoxide. So this is water gas. This water gas mixture is used for the synthesis of very important compounds like methanol and other hydrocarbons also. So that is why the name of water gas is also synthesis gas, or in short it is called syngas. This process is called coal gasification reaction. So this is coal gasification reaction. Now further it is water gas produced here in this step is further reacted with steam. So this is water gas, mixture of hydrogen and carbon monoxide, further reacted with steam to give more hydrogen along with the formation of carbon dioxide also. So this is carried out at 673 Kelvin in the presence of iron chromate. So this is also one of the very important commercial methods. Important commercial method. If you want to prepare pure hydrogen, it is prepared by action of magnesium and sulfuric acid dilute. If we need 99% pure hydrogen, pure hydrogen preparation, it is done by the action of magnesium with acid, that is dilute sulfuric acid. So MgSO4 is formed salt plus dihydrogen gas is formed here. Dihydrogen gas is also obtained from the hydrocarbons by the steam process, that is the action of steam on hydrocarbons. It is also known as steam hydrocarbon process or hydrocarbon steam process. So this is a reaction with the carbon compounds with steam, like methane with steam, this is methane, this is steam. The reaction is carried out at high temperature in the presence of catalyst. To give carbon monoxide and dihydrogen. One of the very important methods is Lane's process. In Lane's process, the reaction is carried out between the water and iron. Water in the form of steam is used in Lane's process. Actually, the Lane's process preparation takes place in two steps. Now, in first step, there is a reaction of the iron with steam. The first part is oxidation process and the second is reduction process. So it is very important method. So during Lane's process, there is reaction of steam and water with red hot iron. So alternatively, steam and this water gas, these are passed over red hot iron. So this process has mainly, Lane's process has mainly two stages. The first is called oxidation state and other is called reduction state. Let us first discuss what is oxidation state. Oxidation stage. During oxidation stage, superheated steam is passed over the iron. So that means it is reaction of iron with steam. Superheated means the temperature is very much elevated. What will happen here? Iron will get oxidized to a magnetic oxide like Fe3O4 along with the formation of dihydrogen here. Plus 161 kilojoule per mole of heat is released. It is exothermic process. And the second, that is reduction stage. During that stage, this iron oxide formed, this magnetic iron oxide formed, it is reduced using a mixture of carbon monoxide and water, means it is reduced with the help of water gas. So Fe3O4, it reacts with carbon monoxide as well as with hydrogen, because mixture of this and this both is called water gas. So what will be formed here? Iron, it is getting reduced here, so that is why it is called reduction stage. Here the iron is getting oxidized, that's why oxidation stage. Here the iron oxide is again getting reduced, that is why it is reduction stage. So here carbon dioxide is formed.
27.
Then iron oxide also reacts with this hydrogen to form, and again it is getting reduced to iron. So this is also one of the very important commercial methods for the preparation of dihydrogen. So this was all about the important preparation methods of dihydrogen, which we have discussed in detail. Go through it. Next time when we will meet, we will do the properties of dihydrogen and its uses. Bye students.